Venky Ganti, head product and engineering at Number Station. I take my coffee in the South Indian, what is called a filter coffee style with chicory root in it, mixed in it. So that's how I like my coffee.
My name is Laurel. I'm a kind of principal engineer, do a lot of ML at Number Station. And I will drink almost any coffee, but some of my favorite is actually camping coffee, where it's unbelievably strong and almost steep like tea. And you usually have it when you're camping or backpacking. And there is nothing quite like it. So, yes.
Welcome back to another edition of the MLOps.community podcast. I am your host, Dimitri Os, and today we were talking with none other than Laurel and Venky, and I've heard that I do not do justice introducing our guests on these little rants that I go on before we actually get into the conversation. So let me tell you about our guest today. Laurel is a principal engineer at Number Station, and before that, she was doing all kinds of cool stuff with Chris Ray, the famous Chris Ray at Stanford. Venky brings over 2 decades of experience in software engineering and technical leadership to Number Stations, and now he is the SVP of Product and Engineering. Before that, he was CEO and co-founder of Mesh Dynamics, the API test automation company, and it got acquired by Google in 2021. Prior to that, he was CTO of Alation, forgive me if I pronounced that incorrectly, Venky. Alation was the enterprise data catalog company, and he helped create the new data catalog product category. And in this conversation with these two bright individuals, we talked all about open source AI and what some of the downsides are of one size fits all LLMs and why they're not ideal, how to make this trade-off between the size of the LLM you're using and the performance that you're looking for. We also, how can we not have someone on from Number Station and not talk about Text-to-SQL? I feel like that was a lot of the conversation because, wow, Text-to-SQL, baby, it's a reality. We also talked about what it means to host and manage private LLMs, what different challenges are, and the verticals, how you can look at problems with especially Text-to-SQL. We went over that quite a bit, as I mentioned. And so we talked about some of the challenges that you may have and also where you can get unequivocal gains, what you can do to make sure that you set yourself up for success. So let's get into it with good old Venky and Laurel. Hope you enjoy. And of course, if you do, we would love a review. I'll see you on the other side. Okay, so we are here with Venky and Laurel. And Laurel, we just found out that you've never heard of Laurel Canyon. I only know of it because there was lots of 60s stuff happening with lots of hippies, I think, back in the day. And a friend tried to get me to read this book that was all about Laurel Canyon. And I think Neil Young was there for a while. I'm not an expert on Laurel Canyon, but I've definitely heard of it. And my name is not Laurel, and I did not live in California. However, your name is Laurel, and you did live in California. You never heard of it.
Yes, although to my credit, none of my friends have ever mentioned Laurel Canyon to me either. So not only am I not aware of it, but no one I know is apparently aware of it. So collectively we have failed, but at least we failed together.
Yeah, even I haven't heard of it for whatever it's worth. Yeah.
Really? Oh, man.
Yeah.
So, well, I guess now we know. Laurel Canyon, I'm going to do a little bit deeper diving into it because I think that it's a cool place, or at least from what I've heard of it, it was a cool place, especially back in the day with all the music and artistic stuff going on there. And speaking of artistic stuff, why don't we just jump right into this whole fun AI boom that you all are on the cutting edge of? I mean, you're both working at Number Station. We've had, I think, Laurel, you came on to the last LLMs in Production conference that we did. And before that, we had Inez. And so I like to say that you're almost like friends of the pod, even though nobody from Number Stations has been on the pod yet. I do feel like I get a front row seat into seeing what you're doing, but it's probably worth, maybe Venky, can you give us a breakdown of what exactly Number Station is doing, and then how you found yourself at Number Station?
Yeah, that's an interesting story as to how I came about. But first, let me back up and say what Number Station is all about. I know Chris Ray and Chris Berger for a couple of years now. I was at Google doing an interesting incubation project there in the commerce space. And then I was itching to get back into the data space. I was talking to Chris Ray and Chris Berger, and one thing led to another. Starting around April or so, we started seriously thinking, oh, you need to get back into the 0 to 1 space. It's not like that's what I love doing. And I like the data space. That's what I realized. And so after talking to other founders, Ines, Sen, and a few others at Number Station, I decided to join the team. And it's super exciting because given all the talent that Number Station has around machine learning, LLM, and technology, and all of those things, so it's clear that we can actually make a dent in how LLMs can be used for various problems around data management, data insights, and so on. So that's what excited me, and I love coming back to the startups. So that's what brought me back. And coming back to what Number Station is all about. So we are building private data LLMs for enterprises. And these private data LLMs, like you all know, they become the platform for enabling various applications on top. One of the key applications that we are targeting is around conversational BI on data, right? So what this does is enables business users to ask questions of their data, the way we ask questions in ChatGPT for general information. So business users can actually ask questions from their data and get responses back, and accurate ones, because these are private data LLMs which understand the enterprise context and so on. So that's one of the key applications. And there are a few other applications that we are hearing from our customers around entity resolution, data wrangling, and that's one of the first papers that came out of Stanford. Ines and Laurel are co-authors of that one. So these guys have sort of led the field in that space.
Excellent. So Laurel, give us your story on how you ended up here.
Yeah, actually, kind of an interesting moment in my career where I wasn't actually planning at all on joining a startup. And I remember actually telling myself when I was in grad school doing data management work that I would never join a startup because it's far too risky. But yeah, ended up doing a postdoc with Chris Ray at the Stanford lab. Worked very closely with one of the co-founders, Sen, for many years. He taught me pretty much everything I know about machine learning, and was kind of on the verge of going off into academia potentially. Was a little dragging my feet some. There was a sense of hesitation, but had joined Number Station really part-time, just kind of having fun, seeing what they were up to. Did some of the work on entity kind of entity resolution. And then started, did some work on these large models, and was fairly convinced that they were sort of going to change how we build applications and interact with our data. Really wanted to explore this further. Didn't really know how it would fit into the academic side of my life at the time. And then I remember being on one of the this meeting that the CEO Auberger gives, and he kind of made this declaration. He was like, "We are a large language model company, like, this is our future, like we're going to bet heavy on these things." And it was like right at this moment where I didn't know what I was going to do, and took that as a sign. And so then signed up completely full time, and have been there ever since. And just am so kind of passionate and excited about what these models can do for engineers, for developers, and kind of just want to be at the forefront of understanding how they work. And have it's been a lot of fun. No regrets.
So Venky, I think there is something that you mentioned that Number Stations does that I am starting to see more of, and I would love to center the conversation around this for the next couple minutes, which is, it's not all just ChatGPT-like use cases where you go and talk with a chatbot, but you said, oh, customers are coming to us and they're saying that they want data wrangling. And how does that even look? And when you say that, I think, wait a minute, is AI just going to be able to do my data pipelines for me? Is that what you're trying to tell me? Or are we still pretty far from that?
So there are multiple stages in data transformation and data wrangling before data is ready for all the analytics work that happens over at data warehouses. So one is the transformation from a source system into the target data warehouse, and that involves schema transformations, data transformations, and some data wrangling and data cleaning there. So data wrangling could be either, I need to match the customer records, like entity resolution. That's one aspect of it. Other aspect is around standardizing column names. So I have state columns abbreviated or fully expanded in some regions. In some other regions, they're abbreviated. So that kind of standardization needs to happen, and null values, all of these have to be filled in, right? So this is all manually intensive. So, and there are various problems that people have to address, the data engineers and data scientists have to address in this space. So the place where we are seeing significant traction is around data entity resolution, matching records, which represent the same entity, but they're represented differently in the database, right? Because they're coming from different sources. So that's one significant area that we are seeing. A lot of customers, like insurance customers, one of our customers is there, and another one in the real estate industry. These kinds of customers are coming in and asking us, oh, we need help here. We have rule-based systems, and these are taking a lot of time to develop and maintain. So instead, can we use something like a large language model and make it efficient as well as accurate enough so that we can put it in production, right? So that's the place where we are seeing a lot of traction in the data cleaning, data wrangling space. Yeah. And coming back to one other point that you raised, are we at a point where we don't need any data engineers anymore to do this? No, we're quite far from that. So we are still assisting these engineers to do the work, both in the transformation. So I need to take this source data and map it to the target schema. That is still a bunch of manual engineering effort that is involved. At some point, we'll have copilots kind of a thing playing a role there, but it is still significant engineering involvement that is necessary. And same here in the data cleaning space too. It's not just LLMs will come and do it. We need some tuning from the engineers. We need the domain experts to guide the LLM to do the right thing. So the engineers will still play a significant role in this. But these LLMs will start assisting these engineers be more productive and more accurate and more efficient in what they do.
Yeah, if anything, what I'm kind of of the belief that chat isn't always the right interface for all the tasks that people do. Like it's great for some things and like is amazing to like hook people and get them really engaged and like great for some nice sort of quick one-off demos. But the one thing it did show us, and especially like GitHub's Copilot, if you're familiar, it's like the coding assistant, which I think is my personal take is like probably one of the most successful applications of these models is that they're built to be copilots. Like they're not there to replace people, right? Like they're very much there to help you go faster, but they're not there to completely wipe away what you do. I mean, it's just there to facilitate your process.
Yeah, 100%. So one thing that I have heard people talk about, and I know anyone who has been a machine learning engineer or a data engineer for probably more than a year or 2 years has seen some hairy SQL being written. And whether that's like a SQL query of like over, I don't know, 100, 200, 300 characters long, you've probably seen way more than anybody. And you've seen like the nastiest of SQL queries being written. One thing that I've heard people say is that when it comes to SQL and how we are piping around this data or using this data, manipulating this data, it's very much like context specific, but not just context specific. It's like very much like the engineer or the person who is writing it has to write it. And there is a little bit of that, like the bus problem where if they get hit by a bus and then tomorrow they don't come in and you have to figure out what is going on with this SQL query, it's going to take you a while. I get the feeling that you have thought about that. quite deeply. And especially when it comes to LLMs, being able to interpret different SQL queries and understand what's going on. How have you seen it match up? Like, does it get it right away? Is it just, how do you know that it's not just hallucinating something? All of those questions that I'm sure you're thinking about day in and day out.
No, Text-to-SQL, again, I came from a data management background, and that has been like a classic problem in the community for decades. Like, can we get this translation to work? And we're actually at a point now where these models can understand a lot of basic SQL syntax, and so we're actually hitting into these much more interesting hard problems around kind of business knowledge and context that, like, I don't even think we were able to even start to grasp that a couple of years ago. So yeah, I mean, these models again are trained over for the most part very public data sets that you could scrape from the web, right? So all kinds of SQL queries and GitHub logs, and they're messy, and people have different patterns and different styles of writing queries, and different databases that they're running over. But these models are kind of jack of all trades, and so they are very good at kind of learning general SQL, right? So if you go and, like, this, I think a classic example for ChatGPT, you go and you ask a query over a very kind of canonical database, like, and there's some databases that are just they're everywhere, right? Customers, like products. And so you'll see it and you'll be like, oh, like, look, it's getting it right, like it's understanding everything. But then the minute you get right, and that's and that's true, like it is, especially for, again, things that are common, but businesses have hundreds of tables that are very kind of crazy columns that are named like nothing but 5 letters, and no one knows what it means except for 2 engineers who built it, and it's being fed into all these pipelines. And so it's the minute you really touch real customer data, the models, like, they guess, and they're not, it's a smart guess. Like, it's as if you put me in front of their data and asked me to answer it. I'd be like, well, I don't know, like, this seems logical. But it's that, as you really just said, like, they will not be able to handle the complexity of what's in their knowledge, because it just hasn't seen any of the company's data, hasn't seen any of their query logs, has no idea what's going on, and there's no way it could, because it was never trained on that data, right? Like, it's kind of a fundamental limitation of these public kind of third-party models. More from a. So, and there's other challenges too in terms of, like, long context and stuff that you've kind of seen a lot, kind of been talked about as well. But the business knowledge is probably the core challenge to overcome.
Yeah, and so there are 2 leaps that I think we need to make to get these LLMs to work, and this complex SQL and complex business knowledge, in fact, right? One is being able to customize the LLM to the data scenarios, right? It could be text-to-SQL or understanding SQL, outputting SQL correctly, and also understanding what kinds of data is there in that particular database or data warehouse, the context around the data when you apply for entity resolution. So there's one leap of around focusing the LLMs, verticalizing the LLMs on that data-related task. That's one. The second is you go into an enterprise, you go into a customer environment, and you look at, then, like Laurel said, you look at the entire schema and the kinds of values that are there in the database, what kinds of queries are happening on that database. So you need to understand all of that context and how people are using the data in that particular database, what kinds of queries are they writing, what is the purpose of each of the query. So understanding that, making the LLMs understand those, and then asking the questions which will actually result in the complex business logic, that makes it a lot more accurate. And those are the 2 kinds of leaps that we need to make actually to get the answers correct. And if you look at the SQL, there are certain pieces which make the SQL really, really long. One is it's like all the case statements, all of those things, right? So how do you get the LLMs to understand and output those? So there are pieces of information that can be input as knowledge to the LLM, and they get the output needed. Yeah.
So it kind of feels like we should go in this direction of one size fits all LLMs versus, like, very verticalized and specific, smaller, I imagine, LLMs, and how you all are looking at it. And especially, Venky, as you're building product, or Laurel, as you're, like, engineering around this, what are the considerations that you're looking at? And are you trying to go smaller? As I feel like that's the trend, is that let's just be as big as we need to be, but no bigger.
Yeah. No, absolutely. And it's been, a great trend to see, because there was that kind of race to see how big these models could get, and then people realizing that maybe you don't need to be. And in my mind, the real insight here is that the minute you go into a verticalized specific space like text-to-SQL, if you think about it, these big models, that are kind of these third-party models, they know a little bit about everything, right? You can go and talk to them about recipes. You can go get SQL back. They can, help you summarize documents, right? Amazing capabilities. But if I'm just care about SQL, like, I don't need 95% of that information. And so you think about it, it's like storage, right? Like, a lot of that information is being, compressed and stored in these models. And so it just also makes a lot of sense that, like, hey, look, if I verticalize, I don't need that. I can really go smaller while maintaining the capabilities. And the minute you're smaller, you're in a space where we're really at this nice middle ground right now where we're at a size like you can host and maintain locally, right? I mean, with some hardware, but like you don't need, like, I can host one of these models on a single GPU for the most part, like a very easy, not easy to set up, but a more reasonably kind of priced piece of hardware. Like, I don't need distributed systems and all that kind of crazy a lot of, you can actually maintain it locally. And so this allows enterprises to go and they can start to own the models. They can start to really customize them on their data because it's in their VPC. They can host it. And again, this will really work because we're in a fairly narrow task, right? And so you have this really nice trade-off where, like, the more verticalized you go, the smaller you can go, and the more you can kind of really take advantage of all the kind of smaller models that we can play with right now.
Yeah. And so one is, small enough, or big enough just to understand and answer the questions that people are interested in. That's one thing. The second is, like Laurel mentioned, the cost of hosting these and us being able to host these in an enterprise VPC easily. So these are what the verticalization and reducing the size of the models helps us. And the second is we can also make it a little more accurate because we feed that context or the specific scenarios that we are going to ask the LLM. And another important one is actually around reducing the hallucinations, right? So one of the things that we can, as a chat GPT, a very one size fits all, anyone can ask any kind of question and the model has to respond. But in the case of data question, so when we get a question, first of all, we can say, oh, is this related to the data kind of question? If you're asking, how is the weather out today? We have the liberty to say, sorry, I cannot answer that, right? So in the data context. So first of all, we need to understand, is this a data related question? And is it something meaningful that as a model, we expect it to answer back? So these kinds of what we call the guardrails around questions and saying, no, I'm not going to answer that. That's one thing. The second is that you're asking a question, there's not enough information for me to answer it accurately, right? So those kinds of things are what we can train these LLMs, these verticalized LLMs, because we know the context, we know the kind of questions that people will be asking and the kinds of responses we are made to give back to the users from a product perspective. Right? So all of those things are what are enabled by verticalizing, reducing the size of the footprint, and adding additional capabilities as necessary.
One thing that I can imagine people have thought about, and I would love to hear your opinions on when it comes to the trade-offs of how do I know whether or not to make it two models that interact well together or just one bigger model? And what do you look at when you're thinking about that and you're building models for people? Like, should we just make this a smaller model and potentially like fine-tuning it on a different type of model or our own open source model? Or should we try and make it a bit more bloated, but we know that it's going to catch all of these edge cases and we have confidence that it's going to be a better experience, even though it's going to have that overhead of being a bigger model? And I say two models, but we can like extrapolate that out to N models, right?
Yeah, that's actually a really interesting question. And I think my immediate reaction would be, when you try to deal with one model that can do multiple things, I mean, if you're just taking it kind of off the shelf and not tweaking it like that can sometimes, could sometimes work, because it is this kind of slightly more general purpose model. But my experience has been, if you really want to customize it to your data and start to train it, it's actually a lot easier from the engineer's perspective to have slightly better task isolation, at least to start, because scoping the problem, and because at the end of the day, like the problem of getting training data hasn't gone away, right? Like it is still in my opinion, the single most important factor to getting a high quality model is the data that comes in. And like this has been true for machine learning and deep learning for years. And so the more well scoped the task, the easier it is, at least from the engineer side, to go and figure out how to turn on the model. So from that perspective, like a little bit more of this kind of ecosystem of the model makes a lot of sense, right? Because then you also get a nice separation where like, hey, look, if one component's performing well and another one isn't, it's much easier to go and just tweak and turn this one on, rather than having to kind of deal with this potentially correlated, kind of complicated larger model that like potentially you try to change its behavior for one task and you end up degrading performance in another task, right? That can get kind of, it's just harder to figure out and maintain. But again, you're right that the system's complexity of multiple smaller models potentially is more where we don't want to go back to these kind of really siloed pipelines like we had before. We'd like to kind of stay in this still general purpose kind of model ecosystem. So it would also be very task dependent as well, and kind of what task you want. If you want a model that can also be able to chat body style things that can ask and answer questions about your entire all the tasks, then that kind of thing feels also more like one general purpose model. So I'd say it really depends on the tasks that you care about, and the infrastructure that you're dealing with, and if you need to fine tune or not. But there's no clear like answer, I don't think, either.
Yeah. I mean, just to add to that, so it's safe to say that we are still exploring the boundaries of these things, like which are general purpose verticalized LLMs in the data space versus we need to find very small specific models for certain kinds of tasks. So multiple criteria come into the play here, right? One is a human asking the question, or is it a system that's asking the question? If it's a system that's asking the question, in the case of entity resolution and so on, well, these can happen millions of times in a day or in a few hours, right? So then we need the system, these LLMs or these models to respond much more efficiently and at low cost. So we need really fine-tuned small models that can be deployed in production at scale and so on. So that's one kind of task which Laurel was saying, this is a task-specific small model that we need to fine-tune for that specific entity resolution task, not just generic entity resolution on that particular customer data and then customer environment even, right? So that's the level of fine-tuning that needs to happen. So we need training data for all of those things and some human help to actually guide the building of the small models. So that's one. But if you take tasks such as SQL, or answering an aggregation query, like give me the sales on the US West Coast for the small and medium business segment in my target customer base, right? So if you ask such a question, it's a human-driven question. People are asking for insights, and that's something that we solve at our customers, like a real estate customer, an insurance customer. All of these guys these business users want to ask these questions and get responses back. So these are human questions, and the rate at which these come in is not that high. So we can keep the model big and the response latency enough for the humans to deal with, and that's one kind of a task. And so the models can be bigger there. And then these same kind of models can potentially be used for data transformation tasks. I have a source schema. Can I use that to transform it into the target schema? So maybe the same model that we learned for the business domain can also be extended or learned for this schema mapping kind of a scenario, which happens once in a while, right? So how related are these tasks? So in that case, the transfer learning can come in, and we can use a model to do both the tasks versus one model where there is a benefit of having information from one specific task to be carried over to the other task as well.
Ops. You have to immerse yourself in the MLOps content. The best way to do it is to subscribe to the MLOps.community podcast. So, good luck and keep learning.
So all of these have to be thought through carefully, and I think we're just scratching the surface there.
Makes 100% sense. And especially one thing that I think we could probably jump into now is like the NSQL foundational models that you all put out, because there are different sizes of these, right? It's not just one size, or is there, I can't remember, what is it, Laurel? 8B and what are the other ones?
Yeah, we have some that are like sub 1 billion, and then up to 7 billion based on the Llama, one of the Llama 2 models that was released like 4 or 5 months ago. Yeah, something. I can't remember. It felt like years ago, but yeah.
Yeah, exactly. And so you mentioned how the hardest part on this is not necessarily what model am I going to use. It's like, what data am I going to use to add to this model to make this model effective and useful? And so when you're working with people, like, what are some challenges that you've seen on the data side, especially when it comes to this idea of like using SQL as your data source? And I know, Venky, you mentioned there's these two sides of the problem a little while ago, where it's like, how are people interacting with the data, and then what does the data look like? What do the schemas look like? So there's those two sides of this problem when it comes to the context and how you want this model to interact. But as far as like training a model for a customer that is able to do these things, like, what kind of data are we talking that we need? And is it just fine tuning, or are you going and you're saying, you know what, we're going to train a whole foundational model too? And maybe what are the different sizes, or how much data do you need at each one of those steps?
Kind of answer that last question first. The more you fine tune, and there's some kind of ML tricks around how you fine tune, and like there's some kind of fancier techniques where you kind of update subsets of the weights. Like, the less you change, roughly speaking, the less data you need from the base model. You know, that's oversimplification. But and so obviously, if you're training completely from scratch, you're gonna need a lot more data from a company. And it's gonna be, you know, more expensive and all that. So so there's kind of that spectrum there, and models right now are good enough that I would question. It's a little unclear. I mean, unless you're like a really new domain where like all, you know, in essence, like how you talk about things is fundamentally different. I think most of the focus is on fine tuning. Or at least kind of continually to update models that already exist, just because there's so much cost and effort that goes into that kind of initial training round that it's not always worth it for companies to kind of repay that cost. Now, in terms of if you're focusing on this kind of fine tuning, like if I wanted to actually customize, you know, give a customer a high quality text-to-SQL model for them, the real challenge is that for the most part, the data that we need doesn't exist, right? Like, they've never, you know, the dream scenario, which doesn't happen, is that, oh, they've like tried to do this text-to-SQL for years and have massive terabytes of the data lying around, but you know, that's never going to happen. And so really, I feel like, and Maggie can elaborate more, two of the challenges that we've dealt with a lot is this idea of how do we walk through the process with a customer of saying, hey, look, you typically have a bunch of log data, a bunch of dumps of data. They actually have a ton of data out there. So how do you help them curate it, and then work with them to go build kind of, you know, we really need to build, you know, kind of evaluation set so that they know what the quality is and we know. So at the end of the day, like when numbers are good, we're all happy. And that's really important so that customers know what they're getting. And how do you get the data labeled and processed, right? Like there is a slew of models you can actually use to help with this. You have to kind of be careful which ones you use and how you do it. And then privacy also comes into play a lot, right? There's some data that it's difficult to share, but it's really like a valuable gold mine. And so there's kind of a whole back and forth that happens around, how easy or hard it is to get access to data that matters. And so it's not an easy thing, and so we're actively figuring it out. But again, is probably one of the most important things is making sure that the data that you kind of walk through with work with the customer to get high quality data and understand what the goals are.
Yep. And just to add to that, from a customer perspective, I think that the two things that they care about, let's say our real estate customers or the insurance customers, they care about, is it accurate? Are the responses that I'm getting, are they accurate enough? And can I actually get it time to value for that? Okay, the number station comes into our environment, and from that point till the time when business users or entity resolution jobs can actually start using those models effectively, how long does it take? Are we talking months? Are we talking like typical BI products out there, which take months for anyone to actually prepare the layers so that the BI tools can sit on top? Or are we talking days to weeks, right? So our promise to these customers is, we'll be up and running in days to weeks. And the place where we actually innovate here is two points. One is we take a one-size-fits-all like Llama model. We verticalize it to the data domains based on the public information that we have on GitHub or on the web and so on, and also Tableau workbooks, those kinds of things. So we verticalize that, and we already have an off-the-shelf number station verticalized model which understands what data context means and what kinds of responses it needs to give, right? So that model is already there at the base. Now we take that and we go into the enterprise environment and going back to my elation days. So what is the context of the data? It's the schema. It's the queries that are running over the schemas. And it's the reports that have been constructed over these schemas, right? So all of this define how people are using that database in the customer. Now we need to give that context to this number station based data LLM, and call it a pre-training phase, which may take a few weeks. And after that, it's ready to be used for that specific context and the specific enterprise customer, right? So that's the way we approach it. And it reduces the time to value to weeks rather than like months, right? So that's the place. And then like Laurel said, we continue fine-tuning after that. So this context is not static, it continues to evolve. So we need to continue the tuning of this private data LLM that we built for that specific enterprise. So that's the ongoing activity that we need to do.
Okay, cool. So I'm going to change gears and go in a bit of a different direction, because since I have both of you on here and I know you're thinking about the LLM space and the foundational model space daily, maybe hourly, potentially, I would love to know where you think things are going and what is going to change in the next 6 to 12 months.
I'm very excited about this. I think, you're seeing a little bit of this with, I was actually just chatting with a friend yesterday about some of the new like Apple MacBooks that just got released that have, like this, it's like unified memory, but basically I think what we're seeing is we're going to start to have a lot more, not necessarily commodity hardware, but it's going to be a lot easier for companies and organizations and even individuals to host and potentially even train local models on laptops, on desktops. But you're still going to need really expensive hardware to like really train these things from scratch. But I think we're going to see this era of potentially, personalization and customization of these models that like we just don't see right now, where you can, again, have a model that stays and lives on your laptop the entire time. And that's a pretty exciting scenario, right? It could get customized to your own, for example, for engineers, like customized to how you code rather than just generic, coding patterns in general. And so I think that's one trend that we're going to see a lot of is these kind of smaller models that do a lot locally, and that's also going to be very exciting. I also think we're going to start to, and we're seeing a lot of work on the academic space slowly start to tease this apart. But a lot of the, again, this is my personal take, but a lot of the advantage OpenAI had, potentially arguably still has a little bit of, is the quality of their data, how they were getting their training data. There has been some articles about, the massive amounts of data labelers that they have to go and kind of curate these very high quality training data sets for these chat models. And I think that moat is already closing, and I think will be closed in the next 6 to 9 months. I think we're going to start to crack open these kind of quote unquote data recipes, so that it's going to be a lot. So in essence, you're going to get open source models, these fingers crossed, that are very much as performant as kind of some of these private third party ones, which again opens the door for a lot of training and tuning and things. So just really democratizing the access to them. So those are kind of two trends I see. I mean, I may be wrong, but we'll see what happens.
Wait, on that last point on the data recipes being democratized, or basically OpenAI not having that edge as much because of the data that they have, you don't think, I would have thought it's going the other way, where since they have so many users and they have so much feedback happening, and they're getting just so much input daily, they are continuing to curate that data set that they have.
That's, I mean, true. I do think they've run into some issues where they can't always use the user data directly anymore. Like I think they can't. I mean, who knows what they were doing originally, but I don't think they're allowed to directly train on, or at least you can certainly opt out, I believe, of training directly on.
So they say. Yeah.
I think it's certainly a useful signal, but I think also some limitations are there. But yeah, I mean, yeah, you just sure, but I also I just think if you look at the Llama models, for example, kind of. I mean, I think in my mind they prove that that is not necessarily true. Again, I do think there's a lot of polishing that goes from 90% of the way there to 98%, which is a lot of this chat polish. And that certainly OpenAI has a lot of advantage on. But I'm still very unconvinced that we won't figure out, because I still don't think they 100% know either. Because a lot of it's if you think about the web, a ton of web queries are kind of messy and not really useful. And so you can just kind of capture what is useful. So yeah, they certainly have a lot of customers and users, but also you can imagine there's a ton of other people using things on the open as well. So we'll see. I'm not convinced that's actually the case, but maybe we'll see.
Yeah, I think my view on this one is, it's both will progress, advance. Both the OpenAI, the data curation will continue to advance and use whatever usage they have and then gain benefit from it. And along the same lines, there is demand for open source models and to advance the technology itself. So there'll be a lot of research going on and contributions from the open source to advance that class of models. I'm sure pretty soon we'll see how to either gather this kind of curated data, tooling around open source tooling, so other people can contribute to enhance these open source models. Perhaps there'll be research that will say, oh, this is how we can actually curate high quality data from noisy information and so on. So there'll be a lot of people that will be contributing into this both sides of the coin, whether it's proprietary OpenAI like models or open source Meta Llama kind of models, right? So both will advance from the technology perspective. And from the customer side, I think the demand for private models, I don't want to send all my context in IP. For a customer, an enterprise customer, or even an SMB customer, their data is their IP, right? So that's what they own, and their value is embedded in that one. So the demand for private LLMs that they can deploy in-house and not lose their IP to someone else outside, which is common across all vendors, is going to increase. So that demand will drive a certain kind of development. Like Laurel said, being able to host small models, the infrastructure will be driven to be able to host these kinds of private LLMs, whether large or small, in VPC. So that demand will continue to grow in the next 6 to 9 months, and we're already seeing that. I mean, among our customer base. So we want private models, and that's where we we deliver the value there.
Yeah, and there's one more trend actually I want to, which I am, I kind of want to. It's slightly more from a technical standpoint, but also actually some really interesting implications that we can pull it off. Is we're getting into the space with models that have much longer context lengths. And you're seeing with some of the Meta Llamas or Meta Llamas, some of the code models, they have up to 100,000 tokens, and roughly you can think of a token as a word. It's not quite that way, but close enough. And so there is this kind of hypothesis about if you had a model with a massive, with, millions of context lengths, which we're not there yet, but soon, maybe, do you even need to fine tune anymore if you can basically take a training data set and insert it into the prompt? So there's some interesting artifacts with these long context models where potentially we can need less and less training, which is, I don't really know exactly what that would imply, but kind of an interesting scenario that we're also touching on. So you're going to see also more long context models come out because it alleviates the burden of having to tune. You can put more context in there and customize the models more easily without having to update them.
Yeah, have you played around with Claude and like the 100,000 context window? Because I remember when it came out, a lot of people were like, well, there goes the whole vector store. We don't need vector stores anymore because of that. And it feels like vector stores haven't really gone anywhere. And the 100,000 context window, it is nice, but it's not necessarily better for most use cases. And it goes back to that trade-off that we were talking about earlier almost. It's a parallel, I would say, on when do you use a bigger model and when do you use a smaller, like very focused model. And so now we're adding like a new spice to the mix of when do you use like a bigger context versus when do you use a fine-tuned. And so there's all these knobs that we're getting to turn now. And because we get to turn these knobs and say, well, this one I want to be a very super focused model that is on a certain flavor of SQL, or I want this coding model to be on Rust, only Rust, or things like that, versus, oh, I want this to be all of SQL or all of coding, et cetera, and I want it to have a gigantic context window so I can just throw my whole GitHub like repo on there and I'm good to go. So it is fascinating to think about like what those implications will have down the line and how we'll be balancing them.
I think a good parallel to consider here is how the database technology evolution happened, right? So there's one kind of database, one type of workload, and soon people started realizing they can do analytics on top of it. Then we got the OLAP kind of engines, and then slowly the cloud engines, Snowflake and column stores preceding those, all of those, that evolution happened, and the segmentation of the workloads, like the OLTP workload, analytics workload, and then you have these unstructured databases, data with unstructured documents, and so on, like MongoDB, right? So all of this workload expansion happens, and then the technology evolves to catch up with all of these things. So similarly, today we have LLMs as one size fits all, or one kind of LLMs, and we are thinking of workloads as one kind of workload, but the workloads are also multifaceted here, different types of workloads, and you'll have different either LLMs or finer models or fine-tuned models, small models coming out of those LLMs, which will address these kind of workloads. So we'll see a similar expansion of the types of LLMs, types of fine-tuning, all of those things will evolve soon.
Oh, I love that analogy there, and I hadn't thought about that, and it makes complete sense on the more that we explore, the more workloads we're going to see and the more flavors of these LLMs we're going to see. And it's very obvious, I think, for all of us and anyone else who's been playing around with LLMs that it's not going to just be GPT-4 that we do everything with. GPT-4 may be what we test with to see if there's a viable solution and see if our thoughts or our MVP actually make sense. And as soon as we see that, okay, this is kind of good, we could try and get there, or yeah, this does pretty well, then you go and you figure out how to really, again, turn those knobs and make it very, very tailored to your specific use case.
I think there was a blog post by Chris Ray at some point, the last mile of the AI or some such thing, where it was like, oh, the foundational models, LLM, will get us 80-90% of the way. But the last mile accuracy, which is demanded by many enterprise applications, that's where you need to actually invest effort into pre-training those things, the new verticalized model or the custom model, and then fine-tuning those to the specific tasks so that accuracy demands those kinds of steps in evolution. And also the time it takes, like going back to the Claude example of 100,000 tokens, yes, that's good, but how long does it take to do the inference, right? So some of these scenarios, you need to respond within less than a second. In that case, you cannot really exploit that 100,000 token limit. You need to have a smaller context length. So all of those kinds of workloads, the scenarios that you have, all of those. If it's a batch job, I don't care about how long each one calls or takes, then yeah, it may be a different application.
Yeah, I've heard about this idea of the AI gateway. I'm not sure if you've played around or heard people talking about that too, where it's like depending on the use case and this workload, you have some kind of gateway that you hit first, and then it will route it to whatever workload you need. Instead of saying, here's a verticalized workload, it's very much like, okay, I understand that this needs to be a larger context window, and then it will route it to that. I was speaking to the creator of DSPy, and I'm not sure if you're familiar with that. It's like an orchestration layer, and the way that they think about bringing all these pipelines into effect, I think is also very novel, and it has a way of abstracting it away, a way of abstraction that is very useful for the end user. And so the last thing I wanted to touch on, because you mentioned this last mile, is around the way that you do evaluation. And Laurel, you mentioned, hey, we have to make sure that we're evaluating things and we're getting a good result when we are giving customers different text-to-SQL models. Have you curated, or is it on a case-by-case basis? Like, how do you do evaluation, and what are you looking at? Like, walk me through that whole process, because I know that's something that a lot of people are struggling with right now too.
I mean, typically these tasks that people really are caring about now are multifaceted, right? Like they both want some kind of free-form text result, and then oftentimes that'll lead into maybe some kind of more classical, like classification tasks or like action tasks where the model has to go do something or call out an API or things like that. And so, when you have something that's a little bit more well-defined, like a classification task, it's a little bit easier to measure, right? Because you're just dealing with sort of more traditional standard labels. And so obviously you want to capture all of that. It gets really tricky when you're dealing with the outputs of freeform text, right? There's metrics that people have to like compare, for example, summarization, right? Like, there are some ways that people can roughly measure the kind of quality of it. But the standard metrics are not great, right? They're fuzzy. And so in terms of that, like the best kind of, I mean, we're still learning and figuring out how to do it. I would say at the end of the day, as long as there's some actionable output that the user cares about, right? For text-to-SQL, it's really hard to actually compare two SQLs. You can, but there's like, you could take a SQL query and rewrite it 25 different ways, and then you're dealing with parsers and stuff, which, again, those tools exist, but at the end of the day, what they really care about is, does the output table match, right? And so, like, you can kind of start to move, if anything, just treating the model output as an intermediate to like the actual final result that the user cares about. And so it's not the best way to, it's not, it's noisy, but at least it starts to help you measure some sense of, is the model doing what you want? But that's something that you need to talk with the customers. Like, what do they really want out of it? Is that they really care about the text? Do they care about the actions that can happen from it, right? And so there's not a one size fits all evaluation either. Like, it's very custom, depending on what you're doing. But is one of the most important first steps of any kind of project down this route, for sure.
And for a certain class of SQL, you can automate that comparison. So it helps to constrain this SQL output to a certain like subclass of all general SQL. So.
Awesome. Well, y'all, this has been incredible. I thank you so much for coming on here. I'm a huge fan of what you're doing, especially with like NSQL and everything at NumberStation. It's always a pleasure to get to chat with you all. And so I encourage anyone who is trying to figure things out, and if they like anything that they heard here, to hit you up. And then I think we'll end it there, unless there's anything that you wanted to say, any questions that I didn't ask that you wish I would have asked.
No, lots of questions, but yeah, thank you. Really enjoyed being on the pod. Yeah, thanks, Demeters.
Yeah, thank you.
Hey, this is Mike Dalbalso, co-founder and CEO of Tecton. MLOps.community is the best way to stay in the loop on the latest MLOps news and best practices. It's also a great way to connect with experts and get support from an amazingly helpful community. Subscribe and stay in the loop.